There is no elevator to success. You have to take the stairs always. Good morning, everyone. Today, we are going to start our peer teaching session. Our team consists of three members myself, Sophymol B.S.,
Myself, Aleena Elsa Raj.
Myself, Archana Sudevan.
Today, we are going to start a new lesson named electromagnetic induction. Electricity and magnetism were considered separate for a decades before. Scientists like Oyster, Ampere, and a few others established the fact that electricity and magnetism are related. They found that moving electric charges produces magnetic field themselves. The experiment of famous Michael Faraday and Joseph Henry came to conclusion that electric current were induced in closed coils when subjected to changing magnetic fields. So the phenomenon in which electric current is generated by varying magnetic field is known as electromagnetic induction. Here we start our electromagnetic induction with a few experiments done by Michael Faraday and Joseph Henry. We always know that Michael Faraday is the father of electricity. So let's see the experiments.
Okay, as what Sophie told, in order to understand the concept of electromagnetic induction, we have to find out some experiments that have done by Faraday and Henry. So are you able to see the screen?
Yes.
Okay. So here we are going to describe some of the experiments that have done by the Michael Faraday and Henry. The first experiment consists of a magnetic coil and a bar magnet. Here is the experiment. Here, what they have done is they have considered a circular coil out of a copper wire, and the ends of the circular coil is connected to a galvanometer. And one of the things that we have to notice in this experiment is that they have not connected a separate battery for this experiment. That is, they are not connected an external circuit, external current supply to this circuit. And what they have done is they are introducing a bar magnet's north pole, and you have seen that the galvanometer get deflected. In the similar way, when they have drawn that bar magnet backward, the galvanometer again deflected, but the deflection was in opposite direction. This indicates that there is a current in the circuit. And now what they have done is they have introduced the south pole of the magnet towards the coil. Again, what happened is that the galvanometer get deflected, but what happened is that it has deflected in the opposite direction, which had done in the north pole direction. So by repeating this experiment by keeping the magnet stationary, we observed that the galvanometer does not deflect it. But what happens in the case of the deflection of the is that when the coil again moves, the galvanometer get deflected. From this, it is understood that the current produced by the relative motion of the coil or the magnet is called induced current and is said to be set up by the induced electromotive force. And one of the facts that we have identified from the experiment is that the introduction of electromagnetic induction, that is the production of an induced EMF in a coil in a closed circuit by the relative motion of magnet and the coil, is called the phenomenon of electromagnetic induction. So there are two major findings that we have drawn from this experiment. And the first one is that it is the relative motion between the magnet and the coil that is responsible for the generation or induction of electric current in the coil. And the second one is that the concept of electromagnetic induction. That is the production of an induced EMF in a coil in a closed circuit by the relative motion of a magnet, and the coil is called the phenomenon of electromagnetic induction. So, hope you understand the first experiment. Now we can move forward to the second experiment.
Okay, so now we have seen what is electromagnetic induction and a related experiment. So in the first experiment, we have taken a coil which is wounded with a copper wire and a bar magnet. That was the first experiment. So now in the second experiment, we are going to take two coils, which is C1 and C2. Okay, so in the C2, what it is being seen is that it is connected to a battery, and thereby there is a current which is passing through it. And in the C1, it is directly connected to a galvanometer. No battery is being connected. Okay, so that is the coil C1 and C2. So now in this experiment, what we are actually going to do is that we are moving one of the coils towards the other one. Here, C1 coil is being moved towards C2, and there you could have seen a deflection. But when it is being held directly as such, there is no deflection, or we can say there is zero deflection. So what can we infer from this is that as we move the coil away or towards, there is a deflection seen in the galvanometer, which is due to the induced current in the C1 coil, and it is being induced due to the electromagnetic field which is being created from the coil C2. Now, we can move C2 towards C1. Then also we can see that the galvanometer connected to C1 has deflected to the opposite direction. Thereby, we can infer that there too, there is a induced current which is passed over to C1. And when it is kept steady, there is no deflection. Now, again, if we are moving back the coil C2 away from C1, there also we could see that there is some sort of deflection which is observed in the galvanometer. So from this, what we can understand is that the relative motion of the two coils has induced a current as well as an EMF in the relative coils. So that is the second experiment. Now we can see the third one.
Okay, now we are going to third experiment done by Joseph Henry and Michael Faraday. Okay, now let's go to the experiment. Have you seen the presentation?
Yes.
Yes, okay. Here, in the latest or in the previous two experiments, we have seen the deflection of galvanometer during the relative motion of magnet and the coils, isn't it? So here we are going to keep the two coils stationary. Here we are going to keep the two coils stationary. The first coil is named C1, second coil is named C2. Okay, here two of them are kept stationary, and coil C1 is connected to galvanometer G. We can see in the figure. The G is our galvanometer is used to identify the presence of current. Okay. While the second coil is connected to a battery through a tapping key K. Okay, here we can see the second coil is connected to a battery, and there is also a key that is named as K. So there is a purpose for key to pass the current or not. Okay. So while doing this, only this is the experiment where we can keep the two coils stationary and what we can see in the galvanometer. So while doing this experiment, we can see some inferences, or we can came to some inferences. Okay, let's go to it. Here we can observe that galvanometers show a momentary deflection when the tapping key is pressed. Here the function is only for key. When the key is on or key is off. When the key is pressed, that means the key is on. There is a momentary deflection can be seen in galvanometer. galvanometer. That means there will be an induced current. There will be an induced current. The pointer in the galvanometer but returns immediately to the zero. That there is not a deflection for a long time. There is only for a moment of time. Then the galvanometer comes to zero back. If the K is held pressed continuously, in the latest experiment, we can see that when the bar magnet is moving, the current is induced. When the coil is moving, the current is induced. But they become into the C1 coil or C2 coil, there is no deflection occurs. That much. Here, when the key is pressed continuously, there is no deflection in the galvanometer. When the key is released, then also a momentary deflection can be seen. The galvanometer is deflected opposite direction. In the previous experiment, we can see that when the baromagnet is removed from the coil, we can see the deflection in the opposite direction. Okay, when the C1 coil is removed from the C2 coil, we can see the deflection in the opposite direction. As such, in here, the key is released, the galvanometer shows a deflection in the opposite direction. It is also observed that the deflection increases dramatically when an iron rod is inserted into the coils along their axis. In this experiment, we can see an axis. Okay, in this axis through we can insert an iron rod for allowing or for understanding the deflection of the galvanometer is more or less. So when we insert an iron rod through this axis, we can see more increases in the deflection. So the third experiment is about the C1 and C2 coil is stationary. Then also there will be a induced current when the key is on for. Okay, so hope you all understood the three experiments. Then go for our follow-up activities. Aleena teacher, the mic is mute. No, teacher. Now also the mic is mute. Teacher, please unmute the mic. Okay.
Sorry for the time lag, my computer gets stuck. So let us move to some review questions in order to understand how much you understand the concept. So here is the review questions for you. The first question is define electromagnetic induction. So we have already discussed what is this electromagnetic induction. And we know that the production of an induced EMF in a coil in a closed circuit by the relative motion of magnet and the coil is known as electromagnetic induction. And the second question for you is, what are the major findings from the experiment done by Faraday using the coil and bar magnet? And you know that there are two major findings that we have derived from the first experiment. That are, we have understand that there is an induced EMF produced in the coil, and the second one is the concept of electromagnetic induction. So you have to answer these questions by yourself. Now let's move to the follow-up activity for the session.
Okay, so here comes the follow-up activity. First one, conduct a seminar on the contributions of Faraday and the hard work behind it. So you need to prepare a seminar report and present it in your WhatsApp group. Now, second one, make coils of different number of turns using insulated copper wire and use magnets of different strength to produce an induced EMF. Present the activity as a recorded video in your WhatsApp group. So that's all for the follow-up activity. And today we have discussed the three main experiments done by Faraday. And I hope that we all have got an idea about the three experiments. That is a relative motion of the coil with respect to the magnet also induces a current. And second one, the relative motion of the coil with another coil, which has already a current, also induces an EMF. And finally, we have discussed about the iron rod inserting to the axis of the coils also shows a deflection in it. So that's all for today's session, and we are signing up. This is me, Archana Sudevan.
Aleena Elsa Raj.
Sophymol B.S. And thank you.
Thank you.
Thank you.